Hey everybody, this is Mr. Piercy, and what I'm going to be doing today is a demonstration that illustrates the relationship of measurements of angles inside of a circle. However, these are not going to be a central angle or an inscribed angle. However, they're going to be angles inside of a circle that will be formed by chords. For the demonstration, I'm going to use a compass protractor and a couple of different pencils here, so that way things don't all blend together by doing anything in pencil. So to start with, we're going to make a circle. Nothing really incredible here, just big enough so that way we can draw on it and make it big enough so that way the things that we draw on it we can measure. So here is my circle, and we'll call this circle L just for something. L. Okay. And what I'm going to do now is I'm going to just draw in a pair of chords, and it doesn't really make a difference which way you do it. I'm going to kind of make mine uh, more side to side, and I'll do this one below the L. Now the thing is, the only asterisk that I might want to put on my instructions here is that the chord that you make cannot be a diameter because we don't want anything that's unique or anything like that. So we have a couple of chords like so. Now each chord is going to create some arcs that it's intercepting here. So we'll call this, let's say, M and N, and we'll say this one is O and P. Now, what I'm going to do here, first of all, is really what I need to do is I need to extend this. And I know I said to make the figure big enough to measure some things on, but I know that with the protractor that I'm using, uh, I'm going to need to extend my lines out a little bit so that way I can actually measure them. So we'll extend this side out here also. So really we're looking at just the chords, even though now I've kind of made this one into a secant. That's not exactly what we want to try and do. All right. Uh, Now, what I'm going to do here is I'm going to add in the central angles that intercept the same arcs. So here I'll do this one in blue. So there is central angle OLP, and then I will do the other central angle here for the other arc, and I'll do that one in a different color. Sometimes when you do these things in class, everybody just has pencils, and you can see with everything kind of overlapping the way it is, it may be difficult for students to read it. And here I'm gonna, again, for the same reason for the protractor that I'm using, I'm gonna just extend my lines out on one side here so that way I can actually get a good measurement off of them. If you have the kind of protractor that has a little dial on it, you can kind of avoid it because you can adjust the dial to see where it's going to intersect the, or where it's going to just follow the angle along the arc of the compass, or protractor rather. Alright, now what we want to know is we want to have some angle measures. Now here, angle M, and let's call this point here, because that's not point L, let's call this point right here, let's call this point K. So angle MKN and angle PKO, Those are vertical angles, so the measurements of those should be the same. So even though I extended them both in both directions, I really only need to measure one of them. So I'm going to go ahead and measure this one here. And looking at this one, it looks to me right at about, let's see, so this would be 65, right at about 66 degrees on mine. And so I have the measurement of angle uh, MKN is equal to 66 degrees. Well, now let's take a measurement of the two central angles that we have. What is the measurement of angle OLP? So let's measure that one now. So using your protractor here, just line it up. And this one looks to be right at about, it's kind of in between 65 and 66. It's a little hard to measure here. I'm going to go ahead and call that one at 65 degrees. And then we're going to do the same thing for our other central angle. We want to know what is the measurement of angle MLN, and see what we get here. So I'm going to turn my paper upside down so I can measure it the way I drew the line out. And this one here looks to be right at about 66, 67 degrees. So we'll call that one right at about 67 degrees from what I can see on my protractor here. Now, believe it or not, there is a relationship here between the measurements of the interior angles, meaning the angles formed by the chords, angle MKN, and the measurements of the arcs that they intercept. Now remember, this arc here, let me go ahead and just add it here, that is equal to the measurement of arc OP, and this one here is equal to the measurement of arc MN. So the measurement of the angle that's inside made by the chords and the measurements of the arcs that they intercept, there is going to be a relationship between them. And what a lot of students, usually if I do this investigation with students in class, I just leave them to it and say, well, okay, we'll figure it out. There's a relationship between those angles. Well, here, what we're looking at is if you take the two arcs that we have, the 65 degree and the 67 degree, if you add those two together and then divide it by 2, you wind up getting the measurement of this. And usually, like I said, when you leave the kids to just kind of squirm and to figure it out for themselves, usually they can at some point say, oh, hey, if I add these two together, it's double this. So we can say divide that by 2 and we can get the measurement of the angle on the inside. So here I'm going to say the measurement of angle MKN will be equal to the average of the two arcs or the two angles. So I'm going to say the measurement of arc OP and the measurement of arc MN. And this is a relatively obscure property about angles inside of a circle. However, it is definitely something that's part of a circle. It's a property that we need to understand, even though it's not something that is widely known. In fact, you may not see this outside of geometry again until maybe your SAT exam, if at all. But that is the relationship that we're seeing here. If I have two chords intersecting inside of a circle, the angles that they create will be equal to the average of the measurement of the arcs that they intercept. So that's it for this demonstration, guys. If you have any questions about anything that you've seen,